Assalamualaikum and good day. Okay, we continue our class with the next part, which is a example of magnetic circuit. Okay, today I will show you. Okay, I last week I show you the what is the procedure, what is the step to solve the magnetic circuit. But commonly I just show you the previous class I just show you the symbol. Okay, now today I will show you the real value. Okay, so how to insert the real value? So you have to prepare, especially when involved in the unit conversion. Okay, you have to remember back on how to do unit conversion for SI unit. Okay, we start today. We continue. Okay, so the first question, the first example is basically a very simple one. Basically a steel ring. Okay, means that a round object. Okay, round object that has a diameter of 160. You have to refer back to your circle knowledge, and then the cross section area is 300 millimeter squared. So it use millimeter. Make sure you convert this into meter. Okay, and you see that the mean diameter means that the center of the circle. I will show it to you later. And then you have to calculate the MMF, okay, given the flux, and then calculate the reluctance, okay, and the magnetic field strength. Assume the relative permeability mu r, okay, is 605. So make sure you understand the question. Okay, for this case, okay, basically a mild steel ring. Okay, so so first you have to either you can draw it or you can imagine it. So basically a ring, something like this. Okay, okay, so basically a perfect ring. Okay, and then the diameter. Okay, the diameter, mean diameter means that at the center to the center. Okay, this one is 160 millimeter. So basically what is length? The length is basically, okay, 2 pi r. So, or pi d equals to, okay, 3.42 multiplied by 160 millimeter. And this is very important. Okay, most of the students previously are wrong here. Don't forget to change this into, okay, into a meter, the standard value. Okay, so change it to millimeter. Okay, so 1000 millimeter is 1 meter. Okay, make sure you use the SI unit. So the answer is using the calculator. So the answer is 0.503. Okay, so meter. Okay, make sure you use meter. Next is the area, which is this one. Okay, the cross section area. Okay, the area is, if given here, is 300 millimeter square. Okay, so how to change this? Remember, you have to use the SI unit. Okay, so multiply by 1 meter divided by 1000 millimeter. Don't forget to square because we have square. So basically change this and you get, okay, so you get 3 multiplied by 10 negative 4. Okay, so meter square. Okay, make sure you know how to change the unit. For area, don't forget 1000, you have to divide 1000 2 times. Okay, so please understand how to convert this. So next you have to calculate the reluctance. So S equals to L divided by mu naught mu R, okay, and A. So for this case, okay, 0.503 divided by, okay, mu naught is, okay, mu naught is 4 pi multiplied by 10 negative 7. Okay, mu R is the relative permeability is given, okay, 605, okay, and then the area is 3 multiplied by 10 negative 4, okay. So using your calculator, you have to calculate this value, okay. Make sure you press your calculator correctly. So the answer is, okay, 205, okay, 2205 370, okay, ampere Weber, ampere over Weber. So this is the reluctance, okay. So for this case, you have to make sure you use a lot of point, okay, because it is very small and very large. Okay, and make sure you practice your calculator, okay. So right now, please take out your calculator and try to insert all of this value, okay, insert all of this value and make sure you get this, okay, just for practice, okay. Just take your calculator and practice inserting this value, okay. Almost many of the student in the previous section, okay, in the previous semester, cannot insert this value into the calculator. So take out your calculator and try to insert this value and try to get the answer, okay. Practice with your calculator. Okay, you can also use 2.2, okay, multiply by 10 6 ampere over Weber. Okay, that is another way to write this answer. Okay, next you have to calculate the MMF. So remember the formula, F is equals to flux S. So you know flux, you know S. So flux is 400 micro, okay, 400 microweber, and the reluctance is 2.2 multiplied by 10 6, okay. So using your calculator, so you get 800, okay, ampere, okay. So actually sometimes we use ampere dot turn, okay. This one also ampere dot turn, okay. Magnetomotive force can be ampere or ampere turn, okay. You get the first question. Okay, how about the second question, which is B, okay, reluctant, okay. So reluctant is basically you already calculate, okay. So you just use the value, okay. And then the magnetic field strength, okay. Magnetic field strength, okay. What is magnetic field strength? So magnetic field strength is H, okay. So where is H? Okay, oh, this one, okay. So use this formula. So H is equals to, okay, F over L, okay. So F is 800 divided by L is 0.503, okay, from here, okay, the L. So you get So you get 1749.5 ampere per meter. Okay, so that is how to answer this. Okay, so this is very simple question. So you have to understand how to do this, and don't forget again, try to insert this value into your calculator. Okay, because this is a very complex number, very complicated number, and you have to be careful when you insert this value into the calculator. Okay, the next example is focus on a series magnetic circuit, but with different dimension. So you can see here the dimension for each. Okay, for some of the location is not the same. So first you have to know to determine the dimension. Okay, the area and the length for each section. Okay, they want you to find the current to produce the 0.05 Weber. Okay, 0.05 Weber, and the relative permeability mu naught, okay, is 1000. Okay, what is the flux density? Okay, you have to calculate the flux density at the right side of the core. Okay, flux density is B. Okay, remember B is equals to flux divided by A. So that is the question. So first I will show you how to determine the dimension. Okay. Okay. So first we focus on the length. Okay. So I suggest you label the location. Okay. So easier for you. So maybe this one is location. Okay. Section 1. This one section 2. This is section 3. This is section 4. And the core depth is 4 cm. So remember when you do this winding, okay, the flux flow like this. Okay, the flux flow like this. Remember the right hand grip rule. So make sure you know the direction of the flux. So when you know the direction of the flux, you can know the L, which is area. L is basically this. Okay, L is the same directly proportional. Okay, not directly, parallel to the flux. Okay, the length is parallel to the flux. Okay, make sure you know that. And for area is perpendicular to the flux, so something like this. Okay, this one, and this one. This is the area. So remember the right hand grip. Okay, the Ampere law, if not mistaken. Okay, so make sure you know the direction of flux, then you know the length and the area. So we start with the first length. Okay, so first length we use okay. So you can see here, remember the mean. Okay, the mean or the effective length means that you have to take the center. So for this one, you can see that this one is 15. So the center is 7.5. Here to here is 7.5. Okay, and then here to here is 15. Okay, and then this one to this one is 7.5. So L1 is basically 7.5 plus 15 plus 7.5. So you get 30 cm. Okay, don't forget to change it into SI unit. So 0.3 meter. Okay. Now how about L2? Okay. So for L2, you can see here, you look here, the center is 5 cm. And then here to here is 20. And then this point to this point, you take the center is 2.5. So basically L2 is 5 plus 20 plus 7.5. Okay, so you get 32.5 cm. Again, convert it 0.325 meter. Okay, make sure you know how to convert this. Okay, for the next part, okay, again use the same concept. Take the center here is 7.5. Okay, 15 divided by 2, 7.5. Okay, this one is 15. Okay, this one is 15 divided by 2, also 7.5. So L3 is basically almost the same as L1. Okay, so you get 0.3 meter. Okay, so basically same as L1. And then lastly, L4. So for L4, so if you look here, this one is the same value as this one. So L4 is basically L2 equals to 0.325 meter. So you get the length. So next part is the cross section. So for the cross section, okay, we start with the first one, area 1. So the area 1, you can see that the width is 10, okay, and the depth is 5. Remember, that's the area is basically perpendicular to the flux. So you have to get this, okay, and the core depth is 5 cm, and this one is 10 cm. So area 1 is basically 10 cm, 10 multiplied by 5, so you get 50 cm, okay, cm squared. Okay, and don't forget to change this, then multiply by 1 divided by 10. Okay, 1 meter divided by 10 cm. Okay, oh sorry, 100 cm. Okay, 100 cm is 1 meter. So don't forget to square because there are square. Okay, so use your calculator. So you get 0.05 meter squared. Okay, that you get the area 1. So you use the same concept for area 2. Okay, so for area 2, okay, you look at the width here, okay, basically here to here, and the depth is, okay, because the flux is moving this way, so the cross section is this one. So this one is basically, okay, 15, and then the core depth is 5. Okay, so you get A2 is 15 multiplied by 5, so you get 15 multiplied by 5 is 75 cm squared, 75 cm squared, and then don't forget to change 10 and 1 meter divided by 100 cm, okay, squared. So you get 0.075 meter squared. Okay, and then so you get what is L3, A3. So same concept, because the flux move like this, so you have to get this cross section. So the cross section is basically this one 5, and then multiply by 5, 5 multiplied by 5, 25 cm squared, and then forget to change it, 1 meter is 100 cm. Okay, don't forget to square, and then 0.025 meter squared. And lastly, A4 is, okay, you can see here, okay, flux move like this, and you take a cross section here, and then you can see that this is 15 and 5. 15 multiplied by 5. So same as A2, okay, is equals to 0.075 meter squared. Okay, so you get the answer for the dimension. Now, after you get the dimension, you can calculate the reluctance. Okay, so remember the reluctance. So S1 is L1 divided by, okay, mu naught mu R. Okay, maybe this one is too complicated, so we just use this one. It's easier. S, okay, because we involve, if it's involved with the same same material, it is easy if you just calculate all the total value. Okay, reluctant total. Okay, so S total is basically L1 divided by mu naught mu R, okay, A1 plus L1 divided by mu naught mu R A2, okay, this one is 2, okay, plus L3 divided by mu naught mu R A3 plus L4 divided by mu naught mu R A4. Okay, this one is 4, this one is 3. Okay, so because it is a same material, so it is easier for you just to group is together, because mu naught and mu R is the same. So ST is equal to 1 over mu naught mu R L1 over A1 plus L2 over A2 plus L3 divided by A3, and lastly L4 divided by A4. Okay, so easier because you have similar value. Okay, if you want to insert this, use this formula also can, but there is a possibility that you insert into your calculator is wrong. So most of the mistake done in the calculator, okay, when you insert the value. Okay, so this is plus. And why just plus? Okay, and why just plus? Because this is a series, so you don't need to do complex, okay, the reluctant division, okay, current division or something like that. Because this is a series, you just plus, okay, because the flux doesn't divide into several circuit, so this is a series. So series just plus together. If parallel, you have to be careful. Series parallel also be careful. But for series, okay, you just plus the reluctant. Okay, so insert the value here. Okay, so ST is equals to 1 over 4 pi multiplied by 10 negative 7. Make sure you memorize this. Okay, it will not be given. And mu R is, okay, 1000, I think. Wait, I check question first. Okay, so relative permeability is 1000. So 1000, and then multiply by all this value. 0.3 divided by 0.05 plus 0.325 divided by 0.075 plus 0.3 divided by 0.025, and lastly plus 0.325 divided by 0.075. So check first, okay, make sure all the value is correct. Okay, so this one is correct, and okay. So make sure you check carefully because it's involved a lot of number. And again, use your calculator. So when you insert the value into your calculator, make sure you be careful. Okay, So try to use your calculator again. So you get the answer is 21751. Okay, 21751 ampere over Weber. So this is the answer. So unfortunately, I forget another zero here. Okay. So basically, you have to change everything back. So this one is 0, 0, 0, and 0. Okay. So be careful. Make sure you count the 0 correctly. If not, you make a mistake like this. So this is the answer. Okay. So 217.51 kilo ampere over Weber. Okay. Again, be careful if you use this. Okay. If you compare the answer here, it's not the same. Okay. Because of the value, the method used. For this case, it use it's calculate the impedance one by one. Okay, you can also do this. Okay, you can use this approach. Okay, but it takes a lot of time because you have to calculate one by one. Okay, this one also calculate one by one. Okay, so it's still the correct answer, but the problem is because if you take only 2 decimal point, there will be a large error at the end. Okay, this approach have a large error. Okay, so for this approach is much more accurate and much more easy because you don't have to calculate one by one. Okay, the answer is a little bit different. Okay, because of the decimal point. So you already get the reluctance, okay, and then you get the flux. So you have to know the current. So and you need to know that there is a number of turns. So how to solve this? So basically, yes, F equals to S flux, and F is equals to I and S flux. Okay, so I is equals to S flux divided by N. So S is 217.51 multiplied by 10 power of 3, and then flux is 0.005. Okay, make sure the 0.005. Okay, divided by number of turn is, okay, if you can see here, this one is the number of turn is 500. So you use your calculator. Okay, so I needed to produce this flux is 2.175 ampere. Okay, that is the amount of current needed to produce this flux in this magnetic circuit. So if you compare the result here, it will be different. Okay, so let me check. Okay, 2.175. Okay, the difference because of the calculation of the reluctance. Okay, and flux density. Yes, so flux density on the top core and the right side of the core. So you have to use this. So basically, so I just show you here. So you have to find the corresponding. Okay, so this one you have to find the area here. Okay, at the top. Okay, the area refer back, it is A2. Okay, you have to use A2. Okay, remember this one A2 because at the top you label it as 2. So use this, and the flux is the same. Okay, because you flux is 0.05, is 0.005. Okay, the flux here. Okay, okay, the flux. Okay, because this is in series, all the flux is the same. Okay, and then you divide by the area here and the area here. Okay, so you get the answer. So area. This one is A4, A3. This one, okay, this one is A. This one is A2. This one is A3. So that is it. That's it. How to solve the magnetic circuit with different dimension. Okay, I mentioned before. This just okay. Just use. If you want to calculate one by one, this is the solution. Okay, this one also. Okay, this one, and lastly, the flux density. Okay, the first example I give before is a simple one. Okay, direct to the point. The second example is different dimension. Okay, length and area is changing. And the third example I show you for different material. So a toroid. Okay, if you don't know what is toroid, it's basically like a donut. So this is the figure of the toroid. Okay, so if you don't know what is toroid, this is toroid. Okay, so this is toroid. So okay, we look back at the question. Okay, a toroid has unknown cross section radius. Okay, so basically if the question is not direct, okay, direct to the point, usually they don't give the initial unknown. Okay, so something like this is unknown. Okay, so basically you have to use algebra. So be careful. They can either want you to find at the end, okay, or they want you to find something at the beginning, but you have to do in algebra. Okay, so the mean circumference, okay, the mean circumference is the center here, the rotation here. Okay, around here. Oh, okay, that one. So that one is L. L is 20 cm. So again, make sure the conversion is correct, 0.2 meter. Okay, the area is, okay, the area is 2 pi r squared, but the radius is unknown, so we don't know. So made of two material divide equally. Okay, means that half of it is one material and half of it is another material. Okay, this one is different material, this one is different material. So let me erase this first. Okay, and then the mu the relative permeability for both material are mu r1 is 1000. Okay, mu r2 is 2000. Okay, you have two materials, so you have two mu. Okay, so make sure you understand this. And the flux, okay, because this is in series, all the material receive the same flux. Okay, flux is 10 milliweber. Okay, make sure you know what is milli. So 0.01 Weber. Okay, make sure in your calculation you use the correct value. And lastly, I is 100 ampere and number of turn is 400. Okay, so you already. So how to solve this? First, of course, you have to calculate the reluctance. So S equals to, okay, so L1, okay, so because it is divide equally, L1 equals to L2 equals to L divided by 2. So total length divided by 2. So L1 divided by mu naught mu r, okay, mu naught mu r. Area is unknown, okay, this one is unknown, okay, plus L2 over mu naught mu r, okay, R1, this one is R2, okay, because there is no mention about different area, all the area is the same. So you can see here L1, okay, so L divided by 2 mu naught mu R1A plus L divided by 2 mu naught mu RA, okay. So again, I suggest you simplify first. So L over 2 mu naught A, okay, 1 over mu R1 plus 1 over mu R2. So insert the value. Okay. So insert the value. L is 0.2. Okay, 2 multiplied by 4 pi multiplied by 10 negative 7. Okay, this one is area. Okay, area is unknown. Okay. Okay, then this one is 1 divided by 1000 plus 1 divided by 2000. Okay, S. So what is S? So there are two unknown right now, S and A. So for this case, okay, you have to calculate the S first. So F, okay, equals to Ni, okay, and equals to S and flux S, okay. So you don't know the S. So S equals to Ni divided by flux. So N is, okay, N is, and where is N? N is 400. Okay, 400, 100, okay, divided by, okay, 10 milliweber, 0.01. 0.01. So S is basically, so S basically 4, okay, 4 multiplied by 10, 6, okay, ampere turn Weber, okay. So this one, okay, this value can insert into this one. So basically, okay, so we move this, okay, move the A is basically 0.2 divided by 2 multiplied by 4 pi multiplied by 10 negative 7, and then S is multiplied by 4 multiplied by 10 negative 6, okay, and then 1 over 1000 plus 1 over 2000. So what is the area is, so the area is 2.98, okay, multiplied by 10 negative 5, okay, meter squared. So again, you use this formula to get the radius, because the question asks you to get the radius. Okay. So what is the radius is, so R equals to square root of A divided by pi. Okay, is it correct? Okay, so square root A divided by, okay, square root A, sorry, square root A divided by pi. So the answer is So the answer is 3.08 millimeter. Okay, so basically this section, okay, this point to this point is basically 3.08 millimeter. So make sure that you know how to insert the value into the calculator. Okay, practice into your calculator, and this one, okay, this one make sure you practice, because of many of the mistake is caused by the calculator. Okay, if you get the answer wrong, you can lose a lot of mark. Okay, make sure you know how to insert the value into calculator. So just take your calculator and practice insert this value. If it's correct, you get the same answer. Okay, and also sometimes the question that involve different material also involve the question on the air gap. So air gap, okay, for A, let me finish the question first. So usually the question continue with add, okay, and air gap is added, okay, 1 millimeter air gap is added, calculate the new reluctance. Okay, remember air gap mu r always 1. Okay, make sure you remember this, mu r always 1 for air gap. So basically for this one, okay, you add a air gap here. Okay, this one is cut a little bit, you add air gap. Okay, there are two possibility. Okay, either you cut it or you make a gap. Okay, so depend on the question. If the question doesn't mention, both can be used. Okay, if gap means that, okay, these two material, okay, are just tear apart. Okay, this one like this, just move it apart. So basically L1 and L2 is the same as before. Okay, however, if the question said that it is cut, means that this one, the material one, this one is material 2. Okay, so basically it been cut. Okay, this one is removed. Okay, from either material. Okay, so for this case, L1 or L2, either L1 or L2 needs to be minus the L gap. Okay, so make sure you understand the question. If the question asks remove, okay, you have to cut. Okay, if gap is added, means that the gap is added, take apart. Okay, if the material is removed, make sure the minus one of the material. Okay, they will mention which one of the material. If the question is not clear, usually you just use this. Okay, if it's not too clear, okay, usually doesn't care actually, because the answer for this one and this one is almost the same, but just you should know. Okay, so how to solve this? So basically you already get the area, you just use back the area. So S total is basically, or S total mu, okay, is basically L1 divided by mu naught mu R1 area, because area you already get here, you just use it back. So plus L2 divided by mu naught mu R2 A, and plus if you add a new gap, air gap, so you have to put the air gap L gap. So divided by mu naught mu R is equal to 1, you just leave it like that, mu naught A. Okay, because mu naught equals to 1, just ignore it. So again, simplify this. Okay, 1 over mu naught, okay, A, so L1 divided by mu R1 plus L2 divided by mu R2 plus L gap divided by mu divided by just L gap, because we already take it out. Okay, so just L gap. So basically take all the calculation. Okay, 1 divided by 4 pi multiplied by 10 negative 7. Okay, area is, so let me check back, is 2.98. Okay, multiplied by 2.98, 10 negative 5. Okay, 2.98 5. Then L1 is, so 0.01. Okay, if not mistaken, so check back. So L is 0.2 meter, so 0.1. So L1 is 0.1 divided by 1000 plus 0.1, also because the same length, divided by 2000. Okay. Okay, if they mention there is a gap, make sure that you minus, okay, minus the a gap. Okay, I will show you later. So plus the L gap is 0.01. Okay, 0.001. Be careful, 1 millimeter is 0.001. Okay, so the S total new is this. Okay, and this one is added. Okay, the gap is added, but if the gap is, okay, the gap is added by removing a part of the material, for example material 1, so make sure you put minus 0.001, this one, the gap, because we have removed the length. Okay, minus 0.001. Okay, but for this case we just use this. So use your calculator, make sure you practice. So the answer is 30.71. Okay, multiplied by 10 negative 10.6. Okay, so ampere dot turn Weber. Okay, make sure you get the same answer using your calculator. Okay, so let me check first. 1 2 3. Yes, 30.71. Okay, that's it for example with different material. Okay, example 3. Okay, another thing that you need to know is fringing effect and flux leakage. Okay, for your course, this one you don't need to know detail, because usually fringing effect and flux leakage is neglected. So make sure you know that if it is neglected, no need to consider. But if you want to know, but you have to know what is fringing effect and flux leakage. Flux leakage is basically, you can see here, the flux should be inside the core, but it goes outside the core. So basically, the flux you calculated is goes outside the core. So that is the flux leakage. How about fringing effect? Fringing effect is basically located at the air gap. Okay, you can see here the flux is bulging out. Okay, basically when the fringing effect occur, the area, okay, for the air gap, the area is increasing. Okay, but for this case you no need to consider this. Okay, because usually it is neglected. This is just to know basic, to know basis. Okay, and of course for this course, okay, only a simple magnetic circuit, if you refer back to your CI course information, only a simple magnetic circuit is considered. Okay, this question is a complex magnetic circuit, parallel magnetic circuit. So if you want to learn about this, you can try, okay, try to answer this. Okay, but if you don't want, it's still okay, because it is actually outside of your syllabus. Okay, if you want to try, it's okay, you can try it, but it's quite complicated, but use the same concept only takes a lot longer time to solve. Okay, that's it for chapter 4. Okay, please know that you have to describe law or concept, okay, and its application. For example, EMF. Okay, so you have to know what is the application for what, for motor, for generator. Okay, so you need to know what is Lorentz law. Okay, and then you have to remember the definition, what is reluctant, what is magnetomotive force. Okay, you have to know what is the definition, memorize it. Okay, what is magnetic field intensity. So next is the explain the magnetic losses and how to solve it. Okay, so you have to know what is the magnetic loss. Okay, so either hysteresis loss or, okay, check back. Okay, and how to solve it. Okay, so there are various approach. For example, eddy current loss, so you use lamination. Okay, so you need to memorize everything, and then lastly to calculate the magnetic circuit. So it can be either direct to the point, you have to calculate the reluctant. Okay, then you have to calculate the given the flux, and you have to find the current. Maybe you have to find the current. Okay, that one is direct to the point. Okay, maybe sometimes it give a fixed a same material but different dimension, so you have to know that each dimension has different reluctance, so you have to ensure that. And then you have to there is also a question like different material. Okay, so you have to consider two different mu r. Okay, relative permeability. Okay, you have to consider that. And also, if the question asks you to have air gap, make sure that you know that air gap mu r is equal to 1. So you have to recalculate again. Okay, make sure you know that. Okay, and then make sure you know how to calculate B and H. Okay, use the formula. Okay, and also don't forget the fringing effect. Okay, and the flux leakage. You have to neglect it. Okay, for your courses, no need to know too much about that. Just know it is there, but for the calculation for your courses, you don't need to do anything. Okay, that's it. Okay, thank you and have a good day.